Today we're going to look at another application problem about quadratics. It's called maximizing area. So we're going to go through this kind of example together, and you'll be filling in some of the work, but I'll try to frame it for you to help you. So the building trades class at Kennett High School is planning to build an additional greenhouse using donated greenhouse panels. The class needs help determining how to best position the panels to maximize the floor area in the greenhouse. Only 3 sides of the greenhouse will require paneling because the 4th side is against the side of the existing building. When the panels are positioned side by side, they stretch 75 feet long. So here's the school. Here's where we're putting on our greenhouse. So the first idea is to have this side be 20 feet long. All right, so what will the length of each side perpendicular to the school be? Right here and right here. So how am I going to figure that out? I have a total of 75 feet. So can I take 75, subtract off 20, and divide by 2? So 75 minus 20 would be 55. Divided by 2 is 27.5 feet. All right, so if x is 27.5 feet, how do I figure out the area of the floor of the greenhouse? The area of a rectangle is length times width, right? So 20 times 27.5 gives me an area of 550 square feet. All right. So if you look down in your table, the length of the greenhouse side that's parallel to the building, parallel is actually over here. So maybe I should have used a different variable here like P or Y. But in this table, when the parallel side was 20, right? How did I figure out the length? I took 75, subtracted 20, and divided by 2. 75 minus 20 divided by 2 came out to 27.5 feet. And then my area was 20 times 27.5, which was 550 feet squared. All right, so I think that you could do the same for example 2. So now this is 45, right? Let's not call this x, right? Let's just call the perpendicular to the school. Because x is really down here, the parallel side becomes x down here, right? So when you're doing example 2, you're actually doing the last row of this table. So if you've got 45, maybe let's do one more together for good measure. We're going to take 75. We're going to subtract off 45, right? So that would give me 30, wouldn't it? Divided by 2 is 15, right? 75 minus 45 is 30. Divided by 2 is 15. So to get the area, 45 times 15, I don't think that that is quite as big. Oh, that's actually bigger. So that actually gives me 675 square feet. All right, so I've done the 20 and the 45. So fill in the table below as the class selects different values for x. So let the parallel side be 10, then let the parallel side be 30. See what you get over here. So you should be able to finish that table. Now, what about if we had to write a function that represents area as a function of x? Hint, you'll need an expression for finding the length of the perpendicular sides as well. So let's think about when we had this as x, what did we do? We took 75, we subtracted x, and then we divided by 2. So let's see, our equation would be, we should simplify it too, but y equals x times 75 minus x divided by 2. All right, so I'm not going to be able to solve this unless I can simplify that to be able to like find the vertex or something. So let's think about how we could simplify this expression. So, and then you are going to finish 5 and 6 because you're going to have a quadratic that you can maximize the area, right, using the vertex. So you can either use the graph or the equation. So let's simplify this equation together. So if I have x times 75 minus x divided by 2, my first step is let's make this two separate pieces. What is 75 divided by 2? 75 divided by 2 is 37 and a half. X times 37 and a half minus 1/2 x, right? So I just can take each of these pieces and divide them by 2. Now I can distribute my x. So I have 37 and a half x minus 1/2 x squared. If I want to finish by putting it in standard form, negative 1/2 x squared plus 37 and a half x. So this is an upside down parabola, right? And so when you either graph it on the calculator or use negative b over 2a, the vertex is going to tell you something important. The x value, right, that's the parallel side length. The y value is going to tell you what the maximum area was. So what is the maximum area? That's going to be the y value of your vertex. Find the dimensions. The x value will be found by the x value of the vertex. And then you'll have to plug that x value back in to this 75 minus x divided by 2 to find this value. So that should be enough information for you to finish this maximizing area problem. Hopefully you can get through the rest of it. Let me know if you need help. I'll take a picture, or you can submit a picture of the front and the back page. And have a great day.